All right, we're going to get started on our next lesson, and this is just part 2 of parallel lines and transversals. So let's start with a little bell work. We've got another equation which we've been practicing quite a bit because solving these angle problems has involved a lot of equations, hasn't it? Okay, so first of all, we get rid of the parentheses by doing the distributive property. And then we notice we have a -6 and a +6 on the right side, and they cancel, they give you just 0. So that just means that we're left with -12 plus 7m equals 10m. So if we minus 7m from both sides of the equation, then we end up with -12 equals 3m. And then we divide both sides by 3, and we end up with m equals -4. So there we go. Hopefully you're getting really good at those because we practice a lot of them. All right, moving along. Let's just review quickly. So we're going to identify the parallel lines. So if you look, we know that lines K and L are the two parallel lines that you can see in the diagram there. All right, there they are. So now the transversal is the line that cuts diagonally across them. And so that would be line M, very clearly seen there. So we ask ourselves how many angles are formed by that transversal. Well, we've got them numbered right there. You got 1, 2, 3, 4, 5, 6, 7, 8. So 8 angles are formed. Which of the angles are congruent? Well, you've got two sets of 4 congruent angles. So angle 1, 6, 3, and 8 are all congruent. And then that would mean all the rest of them are also congruent in their own way. So 2, 5, 7, and 4 are also congruent angles. Okay, let's do some example problems. So given a pair of alternate interior angles, a pair of corresponding angles, and a pair of alternate exterior angles. So I'm circling the 2 different pairs of alternate interior angles, and you could name either one, 3 and 6, or 5 and 4. Now the next one, it says name the corresponding angles. So corresponding angles are angles that are in the same position on the diagram. So I'm going to circle each of the corresponding pairs of angles as well. So 1 and 5, they're in the upper left-hand corner. The next pair would be angle 2 and 6. I hope I've kind of messed that up, and I'll come back and fix that here in just a second. 3 and 7 and 4 and 8 are in corresponding angles, and then I fixed angle 2 and 6 are corresponding angles. So you got 4 pairs of corresponding angles. You only have to name one of them. So the first one I named was 1 and 5, so we'll put that down. How about the alternate exterior angles? These are the angles that are on the opposite side of the transversal on the exterior part of the parallel lines. So I will circle those for you. So we start out with angles 8 and 1, those are alternate exterior, and angle 2 and 7. So I'll pick one out, one of those pairs out, and write it down. So we picked out 1 and 8. But you could have said 7 and 2 as well. Okay, moving along to our next example. So we've got this figure. I want us to, if we are given in this figure the measure of angle 1, which is 136 degrees, then the measure of angle 2 is going to be the angle that makes angle 1 and 2 supplementary, or 180 degrees. So we're just going to do 180 degrees minus 136 degrees, and that equals 44 degrees. Okay? If the measure of angle, and the next problem in part D, if the measure of angle 4 then is 44 degrees, then the measure of angle 8 is also 136 degrees, right? So just using these little relationships that we're developing as we go through these, we can actually, like we said in a previous lesson, if you find one angle, you can find them all. Okay, use the figure to answer these questions. If the measure of angle 8 is 129 degrees, what is the measure of angle 4? Okay, so angle 4 is right next to angle 8, and it would, angle 8 and 4 would add up to 180. So we do 180 minus 129, and we get 51 degrees for angle 4. Okay, now if the measure of angle 3 is 129 degrees, then what is the measure of angle 1? So if 3 is 129 degrees, then the measure of angle 1 is also 129 degrees, because angles 3 and 8 and 6 and 1 are all vertical angles that are equivalent to that 129 degrees. Okay, now in this figure, lines N and K are parallel, and we're going to find the values of X and Y. Well, it turns out that we know that those two angles are 81, and X then is going to be 180 minus 81. So same side and exterior. So that means that the X is equal to 99 degrees. All right, now if we're going to find Y, we have to recognize that 3Y minus 9 equals to that 81 degree amount. So if 3Y minus 9 equals 81, then all I have to do is add 9 to both sides, and I end up with 3Y equals 90. And if I divide both sides by 3, I end up with Y equals 30 degrees. So I've got 30 degrees for Y and 99 degrees for X. Okay, let's try another problem. Got just a few more and we're ready to roll. Okay, in this figure, lines K and H are parallel, and we need to find the value of X and Y. So there's a 74 degree angle there, and then that means that this angle on the other side, on the same side exterior, we can find that by doing 180 minus 74 degrees, and that gives us 106 degrees. So Y is equal to 106 degrees. Now, we also know by vertical angles that 6x minus 58 also equals 74 degrees. So if we set up our little problem, 6x minus 58 equals 74, and we solve for x, then we can answer that question. So we add 58 to both sides, and we have 6x equals 132 degrees. So 6x equals 132. So if I do 132 and divide it by 6, I've got 2 times 12 is 12. We subtract and carry the 2. Oh, look at that. We end up with a value for x of 22 degrees. So x is 22, and we learned a little earlier that y is 106 degrees. Very nice. Okay, what about this example? You're going to see some of these on Canvas, or excuse me, on Alex as well. If two lines are parallel, G and H, are cut by a transversal B, suppose the measure of angle 1 is 65. So I'm going to kind of go through there and label all the angles that are congruent to angle 1. So I notice that angle 1 and 2 are what they call vertical angles, because they're on the opposite side of this little intersection. And so that means that angle 1 and angle 2 are both 65 degree angles. Okay, so if that is the case, then we happen to notice that angles 2 and 3 are in the same upper right-hand corner of each of these intersections. So that would be corresponding. They're in corresponding locations, so they're corresponding angles. And if that's the case, corresponding angles are congruent. So then if that's the case, then if angle 2 is 65, then angle 3 is also 65 degrees. And then angles 1 and 3, if you look at those, they're kind of on alternate exterior sides of the transversal and the parallel lines. So, I mean, there's a couple of different ways you can analyze them. I initially started saying that they were corresponding angles, but it actually turns out that they're not quite in a corresponding position. They're on opposite sides of the transversal. So they are congruent, but they are not corresponding. They are what we call alternate exterior angles. So let me fix that real quick. So angles 1 and 3 are they're in a position which makes them actually vertical angles, if you think about it. So vertical angles or alternate exterior angles. And that makes them congruent. And so if they're congruent, that means they're the same value. And so that's why I've got the value of 65 written up there so that we can see that they are congruent. So when you go through these kind of problems on ALEKS, just kind of look at all of the little menus. And sometimes it might seem a little daunting to figure out which one is correct, but if you're careful and you're willing to go back and kind of fix your mistakes, you should be able to find the right definition in each little drop-down menu that corresponds with the correct answer. So your assignment is on ALEKS, parallel lines and transversals number 2. So good luck and thank you very much for listening.